Okay, so in this video we're going to look at another one of our number systems, the BCD number system. And BCD stands for binary coded decimal. So this is a number system that is written as binary values, but it is a coded system to work with the decimal number system. So this is used like on keypads for a keyboard or anything that has a decimal value that needs to be entered to a circuit. So it's written in binary, but it's coded so that it works directly with decimal. So it's still base 2 in the sense that we're using binary numbers, but it's written as a coded group of 4 numbers. Okay, so again, go through the notes on Blackboard to get familiar with this, and in this video we're just going to focus in on counting and converting with BCD. Alright, so as we always do, starting off with counting. So with BCD, it's always written as a group of 4 numbers. So here I've done 0 through 9 in decimal and 0 through 9 in BCD. So even a 0 is written as 4 zeros because this is a coded number. So it has to be a set number of values, which in this case is 4. So this is the equivalent going 0 through 9. Alright, so because it's based on decimal, this is as far as we can go. 1001 is the highest we can count with BCD. Now obviously with a group of 4 numbers we can go much higher than that as far as a binary value is concerned. But being that it's a coded system with decimal, 1001 is as far as it can go. So to count to 10, this group of 4 goes to all zeros, and then I need another group of 4 to represent the 1. So to write 10 in BCD, I would have a group of 4 to represent the 1 and a group of 4 to represent the 0. Alright, so for 11, this stays the same, 1 and 1. So that represents the 1, this represents the other 1 for 11. 12, this is still going to be a 1, 0, 0, 1, 0 to get 12. 13, 0, 0, 0, 1, 0, 0, 1, 1. 14, that's still a 1, 0, 1, 0, 0. A 1 and the 4 gives me 14. 15. 16. 3 ones there give me 7 to give me 17. 18 would be a 1 in the 8's place. So 1 and 8 is 18. 19. 1, 0, 0, 1 to get 19. And then 20, this is as far as we can go. So this group goes back to all zeros. The next one goes to a 2, so that'll be 0, 1, 1, 0. So that's 20. And then 21 would be 0, 0, 1, 0, 0, 0, 0, 1 for 21. And so on we could go. Alright, so it's a blend of binary and hexadecimal in a way, because we remember in hexadecimal we talked about doing groups of 4. So it's kind of a blend of that. Just know that each place value in decimal is a group of 4 in BCD. All right. So again, just giving you a random number to start counting from, and then going from there. All right. So here we have 0, 1, 0, 1, 1, 0, 0, 0. All right. So for this, it might be easier to, in your mind, go ahead and convert this to what it actually is in decimal. So this would be 8, 4, 2, 1, right? So this is 4 and 1, which is a 5, and this is a 1 in the 8's place, so that's 58. So the next one's going to be 59, right? And then we have 60. So 0, 1, 1, 0, because 2 and 4 give me 6, and then this is all zeros. So that's 60, and then 61, 62, 63, 64, 1 in the 4's place, 65, 66, 67, 68, 69, and then 70. So 0, 1, 1, 1, right? 4, 2, and 1 gives me a 7, and then all zeros here. All right, and then this is going to continue, right, for a while. So you got 71, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I've already went further than I had planned, but that's all right. So 79, 80, 1 in the 8's place, 4 zeros. Okay, so once you memorize that 1 through 9 pattern, it's pretty easy to do. Okay, so again, each place value in decimal is worth a group of 4 in BCD. All right, so that's our counting. Let's jump into converting the BCD numbers to decimal. All right, so real easy to do. Basically the same approach as we took with hexadecimal, in that we use groups of 4. So we use the first 4 place values of the binary number line. All right, so just in case you hadn't memorized that yet, 1, 2, 4, 8, 1, 2, 4, 8. So here we're going from BCD to decimal. So I add up where the ones are. So I have 4, 2, and 1. So that's a 7. And I have a 1 in the 2's place. So that's a 2. So that's 27. Okay. So the next one, 1, 2, 4, 8. 1, 2, 4, 8. 1, 2, 4, 8. So I have 4 and 2 is 6. 8 and 1 is 9. And 1 in the 1 place. So that's 196. Okay, so here I've got 1 in the 8's place is an 8. Here I've got 1 in the 4's place, so that's a 4. And here I have 2 and 1, which is 3. So that is 348. The last one here, I've got a 1 in the 4's place. I've got all zeros, so that's a 0. I've got a 4 and a 1, which is 5. So that's 504. Okay, so very easy to do conversion. Remember just the first 4 places of your binary number line to do the conversions. Alright, so next looking at going from decimal to BCD, just the opposite approach. So each single place value in decimal is worth a group of 4 in BCD. So even if it's a 0, remember it's going to be 4 zeros. So it has to be a group of 4. So 7 is 0, 1, 1, 1, right? 4, 2, and 1 is 7. And then a 1 in the ones place. So that's 3 zeros and a 1. So that's 17. Alright, now I have 85. So for 5 is 0, 1, 0, 1. Because I have 4 and 1 is 5. And then I have an 8. So that's just 1 in the 8's place. So 1 and 3 zeros is 8 and 5, 85. Alright, next I have 530. So the 0 is 4 zeros. A 3 is 2 plus 1 gives me 3. And a 5, 0, 1, 0, 1. Okay. And then the last one, 962. So the 2 is 0, 0, 1, 0 for a 1 in the 2's place. A 6 is 4 plus 2, so that's 0, 1, 1, 0. And then 9 is 8 and 1, so 1, 0, 0, 1. Okay? So again, use that 1, 2, 4, 8 across each group. I didn't write those here, but you can certainly do that if you need to. But that's all there is to it. Okay, so just remember these are separated groups. So when you write these out, do leave some space in between there. Okay, so in the other conversions, we took those groups and we put it all together to get one binary number. But here it's a coded system that we're talking about, so it should be spaced because it's distinct groups of 4 numbers to represent each place value in decimal. Okay, so that is BCD, binary coded decimal. Hope this helps. Again, if you need to, go back through the notes on Blackboard. And if you have any questions on this, please let me know. Thank you.